Good morning, everybody. So today, the first video is going to talk about arcs and chords. So remember, a chord is a segment that goes from side to side of a circle. It does not have to go through the middle, but it can. So here I have 4 chords in this picture. We also need to know that if my segments are congruent, so if RS is congruent to TV, then this section, the arc that it creates, remember the arc is part of the outside of the circle, will also be congruent. So arc RS will be the same as arc TV. Okay. This will help me find different measurements of angles in a little bit. It'll also help me determine the arc measurements. Okay. So if we come down here, you can look at this example if you want. It's posted, kind of walks you through it. If I look at this, it says each regular polygon. So regular means that all the angles and sides are congruent. Is inscribed in a circle. Inscribed means it's all the vertices are on the circle, but it's inside of the circle. Determine the measure of each arc that corresponds to the side of the polygon. All right, I'm going to do my best to draw this. So here's my circle. If we're doing a hexagon, remember hexagon has 6 sides. So 1, 2, 3, 4, 5, and 6. We're going to pretend that all of these are congruent and that all my vertices touch. If we want to know the measurement, the degrees of that arc, if I look, I notice that this hexagon split this circle up into 6 pieces. I'm going to run out of colors. I only have 5. That's okay. We can see them. So there's 1, 2, 3, 4, 5, and 6 sections. Because all of my sides are congruent, that means all of these pieces are also congruent. Remember, there are 360 degrees in a circle. So if I divide that by 6 congruent pieces, it tells me that each section is 60 degrees. So really all we had to do was 360 divided by how many sides. Okay. So if you think about a pentagon, 360 divided by how many sides are in a pentagon? 5. 360 divided by 5 tells me 72 degrees. So if I were to draw a circle like this, but only draw 5 sides instead of 6, it's going to split it up into 5 equal pieces, all of 72 degrees. All right, so let's think about a triangle. See if I can draw this. Oh, that's an oval. Let's try to draw a circle. Yep, here's my circle. Draw my triangle. All 3 sides of my triangle have to be the same size. Notice this time it splits the circle up into 3 even pieces. Because I know those 3 even pieces have to total 360. Do 360 divided by 3, which tells me each one is 120 degrees. Okay, and we can keep going. Same idea. So square has 4 sides. Octagon, remember, has 8. And then obviously a 36gon has 36 sides. So you would just do 360 divided by 36. Whoa, that was messy. And that's going to tell me that each one is 10 degrees. Okay. Same idea down here. Determine the measure of each arc of the circle circumscribed about the polygon. So the circle is on the outside of the polygon. All right. If this is a rectangle in here, we know that UT is congruent to RS. If UT is congruent to RS, if this section is 4x, this will also be congruent, and this section will be 4x. Likewise, TS will be congruent to UR, and if this one is 2x, this one also is 2x. Again, because I know there are 360 degrees in a circle, if I add all of these up together, I know that it is going to total 360 degrees. Combine my like terms. 4x plus 2x is 6x, plus 4x is 10x, plus 2x is 12x. Solve for x, I'm going to divide by 12, and x equals 30. So the question asked me to find the measurement of each arc. So if x is 30, I'm going to plug that in. 4 times 30 is 120. 2 times 30 is 60. This one's also 120, and this one's also 60. So if I add them up, I can test to make sure that it does equal 360, and it does. Okay. So these ones give me markers. It says that TU is congruent to UV. If they are congruent, the arc that they create is going to be congruent. This one's 7x. This one's going to be the same thing. It's also going to be 7x. I know there's 360 degrees. So 7x and 7x and 4x has to total 360 degrees. Again, combine my like terms. 7x and 7x is 14x, plus 4x is 18x. Divide by 18, x equals 20. Plug that in. 7 times 20 is 140. 4 times 20 is 80. We just said 7 times x was 140. Again, I can add them up, check to make sure they do equal 360. All right, last one like this. All right, so I know that these three pieces are congruent, which tells me that these three pieces have to be the same measurement. Okay, because they take up half the circle, that tells me that they're going to total 180 degrees because they are half the circle. So there's 1, 2, 3 sections, and they have to be evenly divided in 180 degrees. Tells me each one of them is 60. 60, 60, and 60 gives me the 180. On the other side, oops, use different color. On this other side, that's the other half of the circle. So this one would also have to be 180 degrees. So remember, 360 degrees in a circle, 180 degrees in half of a circle. Okay. All right, so we're going to use some of the similar information. We also need to know that in a diameter, if the diameter is perpendicular to a chord, perpendicular means it creates a right angle, it's going to split the chord into 2 equal pieces. Okay, so same on here and on here. Okay, so AX is going to be congruent to XB, RY is going to be congruent to YS. Okay. In this case, we'll be able to use Pythagorean theorem. Remember, Pythagorean theorem is a squared plus b squared equals c squared. We're going to use that frequently in this part in order to find missing sides. Typically my radii, or radius, in this, we will use Pythagorean theorem. Okay. So my suggestion when you get problems like this is to look at the picture and find out everything you can first before you try to answer the question. So my first thing says that all of CD is 24 and that the measure of arc CY is going to be 45. Okay. If I zoom in, okay, if all of CD is 24, it split it into 2 equal pieces. So half of 24 is 12. So each one of those is 12. Okay. If the measurement of the segments are the same, and the arcs are also going to be the same, I shouldn't have used that color. Okay. This one's also going to be 45. All right. A little bit of information on these. My other one is also going to be the same as long as they are equidistant, which we're going to assume they are. So if C to R is 12, R to D is 12, AQ is 12, BQ is 12, and then the arcs that they create are going to be the same measurement. So they are both going to be 45 also. So I went through and found all my information before I even tried to answer any question. Okay. Then I just had to look back at my picture and find my information. So AQ, if I look at my picture, we said was 12. RC, again, we said was 12. QB, 12. AB, so AB is the whole length. 12 plus 12 is 24. The measure of arc DY, we said was 45. See how much easier it is once we've already filled out everything in. AB, so we had 45 and 45, which gives me 90. AX, just a little piece, we said was 45. XB, again, we said was 45. Last but not least, all of CD, 45 and 45 is 90. So again, my recommendation is look at the picture, find all your information, and then go back and answer your questions, especially if nothing is changing. That way you're not having to go back and forth and figure things out. You're literally just reading off the picture at that point. All right, in circle G, DG is congruent to GU. So DG, GU, so GU is 3, DG has to be 3. Doesn't bother me. We also know that AC, we don't know what the length is congruent to RT. So I'm going to mark them so I remember. AC is congruent to RT. We're going to find each measurement. So if I zoom in, I notice right here, I'm not going to use that, I'm going to use this. Right here, I have a right triangle. In order to find the missing side of a right triangle, I'm going to use Pythagorean theorem. So 3 squared plus b squared equals 5 squared. 3 squared is 9. B squared is, 5 squared is 25. Subtract 9. Take the square root of b, and b equals 4. Okay, so TU is 4, which means UR also has to be 4, which means AD is 4, and CD is 4. Okay, let's hope that that's enough information right now. It's not going to be. Okay, TU, we just said was 4. TR, if I look at the whole picture, it's 4 and 4, which is 8. The measurement of TS, we're going to come back to finding the measure of TS because we didn't fill that one out already. CD, we said was 4. GD, we said was 3 because it was congruent to GU. And the measure of AB. So we need to figure out both the measure of TS and the measure of AB, which we know in this case are going to be the same measurement since they are in the same spot. Okay, and they have similar sections. Right. In order to find the measurement of these arcs, the only thing we could know is if we knew this angle in here. Unfortunately, they did not give me that angle. So from yesterday, remember that central angles are the same measurement as the arcs. So we're going to have to think back to our trig functions. Remember we talked about them briefly the other day. So, TOA. Right. I'm going to use my 3 and my 5 because they were given. So from my angle, that's my adjacent and my hypotenuse, which we notice is cosine. So cosine of my angle, because I don't know what it is, equals 3 over 5. To get rid of cosine, I take the cosine inverse of both sides, because that's what cancels out cosine. So theta is going to equal the cosine inverse of 3/5. In order to figure that value out, I need to go to my calculator on Desmos. See if I have Desmos pulled up. I don't again. One of these days I'm going to have my stuff together. Okay. And I need to make sure that I am in degrees. So I came over here to my little wrench and I'm in degrees. I go to my functions because I want cosine inverse and 3/5. Okay. Which tells me it is 53.13. Okay, so this one is 53.13. Thankfully, if this one is 53.13, so is AB, and I don't have to do any additional calculations. Okay. Last but not least on this page, a chord of a circle 20 inches long is 24 inches from the center of the chord, or from the center of the circle by the length of the radius. So whenever there's a word problem, the first thing I'm going to do is draw a picture. So here's my picture. It says I have a chord that is 20 inches long. It says that it is 24 inches from the center. Here's 24. We want to find the length of the radius. So we want to find how far is it from here to here? Because remember, radius goes from the center to the outside of the circle. So if the entire thing is 20, that tells me this piece is 10 and this is 10. I have a right angle or right triangle to use my Pythagorean theorem. So 10 squared plus 24 squared equals my hypotenuse squared, or c squared. 10 squared is 100. 24 squared, I can't think what that is off the top of my head. 24 squared is 576. Combine my like terms. 100 plus 576 is 676. And of course, we're going to take the square root of 676 to find out that my hypotenuse is 26 inches. All right. If you have any questions, feel free to message me so that I can help you out. And I will be doing a Google Meet today from 1 to 2 if you need any additional help.